Hello there, this is Alex from Secret Labs, and today I want to demo our cooperation with Fetch AI and how we deployed a Fetch AI agent-first agent inside a secret VM and why this is interesting. So now we're looking at an agent running on Fetch AI agent-first. We chose a simple agent that is one of Fetch's financial agents, and it's called a stocks price agent, and its role is to actually return stock prices upon request from a user or another agent. And of course, we need to be able to trust this agent, right? And by this, we're doing by deploying it inside a secret VM. Secret VM is a TE-based technology. It's actually a confidential virtual machine that has two important properties. A, all the information that is sent to the machine is totally protected from the owner of the hardware. And B, users can verify the authenticity of the code that's running on the virtual machine. Why it's important? It's important for the stock price agent because when I query for stock prices, I want to be sure that nobody's trying to manipulate and give me a wrong price. That's why it's so important that I can check the exact source code that's running on the agent. And why privacy is important, because I don't want the owner of the machine on which the agent is running to know which stock I'm querying, because maybe that would disclose my trading strategy or my preferences. So that's clear. All right, the agent is actually deployed at this URL, Fetch AI Secret Agent secretlabs.com. We can see that it's running on that URL. Okay, the agent is running. We can even talk to it using a little Python program that we created. Let's see the program right here. Let's go client agent, and actually what it does, it takes the address of the stock price agent. We can see it right here. It's exactly the same address. And it asks the agent for prices for Amazon and Apple. Let's try to run it. And indeed, we can see that the prompts were sent and the responses were received. Okay, so all the secret VMs have an endpoint that exposes the CPU attestation of the agent. The CPU attestation quote is actually a cryptographically signed data structure that has a lot of information and which can be used to check the authenticity of the hardware and of the virtual machine itself, and also to see the measurements of all the components of the virtual machine, starting from the firmware and ending with the actual workload that is running on the machine. So let's take this attestation and try to verify it. Okay, we'll go here, we'll paste it here, and we'll get the values of the attestation registers. We will need them a little bit later in this demonstration. So let's go back to the secret VM. It's running our agent, and see the Docker Compose file. So this Docker Compose file actually references a specific package that we built, a package that contains the Fetch AI stock price agent version 002. And we can go to our GitHub and see the package here. And if we go to GitHub Actions, we can see the actual action that built it. And in the action, we can see the specific commit that references the specific source code that was used to build the image. So now, if we can prove that the agent is running exactly this Docker Compose file, then we can establish a chain of trust from the Docker Compose to the image to the actual source code from which the image was built, and everything can be verified in GitHub logs. Now, how do we prove that the machine is actually running this particular Docker? To do that, we actually use the attestation registers. So when we verified the attestation before, we got the values of the registers that measure the VM components, such as the firmware, the bootloader, and its components, the kernel and the init-ramfs, and the RTMR3 actually measures the root file system and the Docker Compose file. All the components of the virtual machine are open source and can be observed in our GitHub. In order to validate that the machine is actually running this specific Docker that we think it is running, we can use a tool that we have created. It's called reproduce-mr. And this is a command line tool that actually allows you to feed it with all the components of the virtual machine, including the Docker Compose file. And the tool actually calculates the values of all the registers. And as we can see, the values of all the registers are exactly the same, meaning that the Docker Compose file that we're looking at is exactly the same. I could even do a little demonstration. And as you can see, the Docker Compose file is exactly what we saw. Let's try to change something in the Docker Compose file here. Let's change to version 3, save, and try to run reproduce-mr. So what we see now is that RTMR3 changed. Okay, all the other registers are the same, but the RTMR3 changed, meaning that if I change a single symbol inside my Docker file, the attestation would change, and that the user would be able to see that something is wrong and then the source code is tampered with. So this concludes our little demonstration. So I'll just recap. We have a Fetch AI agent that's deployed inside a secret VM running on the Secret AI developer portal. And we have shown, albeit very briefly, how we can establish the chain of trust between the agent or the virtual machine and the exact source code that it is running. Thank you.